So, today we're going to be talking about the ideal gas law, more specifically when it relates to volume and moles of gas. But first, let's go over the entire equation for the ideal gas law, and then we'll get more into the specifics. So right here we have pressure, which is the P. Here we have volume, moles of gas, which is N, R, which is the constant in this equation, and T, which is temperature. So for our first example, we have a balloon. So, as I blow air into it, that is going to represent the moles of gas going inside. So let's see what happens. So we see when N moles of gas grew inside this container, the volume also increased along with the balloon. We see that in the instance with the balloon, that there's a direct correlation between the amount of gas and the volume. When the gas goes up, the volume also goes up, and when the gas goes down, the volume goes down, showing a direct relationship. This is because this is a non-rigid structure. Here we could see that on the bottom, as the moles of gas are leaving the balloon, the volume also begins to decrease. And on the top, when the moles of gas begins to increase, the volume also increases, showing a direct relationship. However, when we look at something more solid like this glass, we could see that regardless of how many moles are going into this is not going to change the volume of this glass because this is a more rigid surface. This means that in the case of this, it changes in the fact that we will not see an increase of volume with an increase of moles of gas. We may see something like an increase of pressure, but this does not, however, affect the relationship between moles of gas and volume. The conclusions we could draw from this experiment is that in a non-rigid container, as the moles of gas goes up, so does the volume. And with a non-rigid container, as the moles of gas goes up, the volume does not change, and while other variables may change, the actual volume does not.